The next application we're going to build is all about voting. Traditionally, democratic governments hold elections and collect votes from the population. There's a multitude of ways that people can vote, but verification is still a very human process. Votes are added to a ledger, and after a long period of time, the results will be released. Using blockchain technology, we'll not only be able to immediately calculate the votes, but we'll also be able to instantly verify a user voting using key pairs. In this project, you'll learn how to manage accounts and build using program-derived addresses with best practices. Let's get started. Hello, my name is Jacob Creech, and we're going to be building the voting application. Before we get started on that, we have to build up our local environment to actually build our voting application. This is contrary to the previous application that you built, the Favorites app. We're going to build it locally versus all within the Solana playground. So let's get started on how you set up your local environment. All right, so first thing that you need to do is you'll need to install Rust. And the web page that I'm looking at right here is the Anchor docs for installation, and it has a full list of all the different things you need to install. So first thing we're going to do is install Rust. We go to this website, and we just use this command. So let's go type it into our command prompt and let it run. So this will just make sure everything is set up on our computer to use Rust to compile Anchor and other Solana smart contracts. All right, so this is going to update my Rust home variable. It's just giving me all the information to do the installation, and so I want to just proceed with standard installation. And here we go. All right, so now we've had Rust installed, and the next thing we do, as it says, is we have to make sure that we reload the path variable. So we can see that here we need to make sure that to configure current shell, you need to source the corresponding environment variable under home cargo. It's usually done by cargo environment or cargo environment fish, depending on what you're using. You'll have to know exactly what your current installation is or whatever type of computer you're using, but this should give you the right information to do the correct thing. So let's go make sure that we have Rust up. I believe it's just Rust up. Yep. So we typed in Rust up, and we can do Rust up -- version, and it'll tell us that I installed Rust up 1.27.1. We're all good to go, and we can see my active Rust version is 1.79.0. So that is everything that you can see. They're like, oh, I have properly installed Rust on my computer. And the next step that we need to do is we need to install the actual Solana toolchain. This is so that we can do a bunch of different Solana-related things like creating key pairs locally or compiling our smart contracts and more. So we click here, and it'll take us to the page to do the installation. So we can see here that there is a CLI command to install. We just copy and paste it into our terminal. So let me paste it right here. And this will pull down the Solana binary in order to run the Solana toolchain locally. All right, so now we see that it was installed. We've installed Solana version 1.18.18, and it's telling us to do an export onto the path. So we can just run this thing right here, and it will export our binary using Solana onto our path variable. This just basically allows us to use the Solana CLI. So then we can open a new terminal. Let me make it bigger for you all. And we can type in Solana -- version, and it should give us the version number. And see here we have Solana CLI 1.18.18 installed. So we're good to go. We can also check in this other terminal just to make sure that we did everything correctly on the Rust version. There we go. And we have 1.27.1. So let's clear this and close out of this terminal. All right, so we're back to here, and we keep following the docs pages. The next thing that it has us do is we're installing Yarn. You can also install npm, you can install pnpm, you can use bun. You can do whatever flavor of package manager you use for JavaScript, doesn't matter. This one says install Yarn. I'm not going to show this because it's like there's pretty good documentation out there because it's outside of our ecosystem. So go ahead and install your favorite package manager for using Node.js or something, or JavaScript. The next thing we need to do is we need to use the Anchor version manager. This is so that we can have the correct version of the Anchor framework locally in order to compile smart contracts on Solana. So this just tells us to do cargo install. So let's go ahead and do that. All right, and that's Anchor installed. So you can see that it installed 0.30.1, and we can go open a new terminal and see if it actually worked correctly. So let's make this bigger for y'all. avm -- version, and we can see 0.30.1. And in order to set your current Anchor version locally, because this is just the version manager, you do Anchor or avm use. We're going to use 0.30.1 throughout this boot camp. And now we're using 0.30.1. So that should have everything that you need to get started, I believe. Let's just double check with the docs. All right, so this has some more information to make sure that you have everything right. It also tells you to do Anchor -- version to make sure we're using 0.30.1. And so we have Anchor CLI 0.30.1. So now the next step is what we're going to do is we're going to set up our project for creating the voting app. I'm going to just make sure I'm in a good directory that I like. I'm going to make a temporary directory for us. There we go. Let's make sure. Bootcamp temporary. All right, so here what I'm going to do is I'm going to do let's make sure it's bigger. All right, so here what I'm going to do is I'm going to do npx create -solana -dapp. And you just type in that and hit enter. And what this does is it will create a scaffold for building all your different projects locally on Solana. So here we first got to enter our project name. We're doing a voting dapp. We're going to use Next.js for this. We're going to use Tailwind. We might as well have the counter program. That's fine. And it'll start creating the workspace. And so once this finishes, we'll have a template or a scaffold in order to start building our voting app locally. This makes things a lot faster locally as well. All right, so we've created our template Solana project, and we can actually start running it. So if you go, we can do ls here, and we can see that there's a voting dapp folder now. We'll go cd into it. And if we do an npmi, I used npm locally, that's fine. So we can install the npm modules to get our web front end running, and then we'll do a npm run dev to run our actual website. So npm run dev, and it will open on localhost 3000. So let's go look at localhost 3000, see what presented us. All right, so this is basically a placeholder or a scaffold for us to create our application. This is what we're going to use completely to build out our voting application within Solana. We have everything here. There's a bunch of placeholder stuff that we'll remove later on. We're going to focus on the program side first, or the smart contract side, and build that out. All right, so let's go look at our other local stuff. So going back to here, we're going to open another new terminal. So another thing about local is that instead of running things on DevNet or our environment that's not on your local computer, we're actually going to run a validator locally that has a lot of the same capabilities that you would see in a validator on the actual live network. And we can just simply do this with the Solana toolchain by running Solana test validator. So you want to run this locally also to test to make sure everything installed correctly. Just as a note, if you're using Windows, you will want to have this all installed on WSL. Otherwise, it might not work. And what you can see here, the JSON validator is running on port 8899, and it's processing slots. You can see it's at slot, what is this, 1,300,000. And the confirmed slot is moving forward, and we're all good to go. And it's running. And so actually, if I run this and I click here and click on local, you can do things on local. So you can probably, let's say we can see it in accounts. I can see that I have an account with this much SOL on local, no token accounts and everything. This is the majority of your time is going to be spent using the local validator to build Solana smart contracts. Another thing is locally, you can use the Explorer to look at everything that's happening on your local validator. You don't have to go do some API calls or something to figure out what's happening. You can all do it via the UI on the website. And how you do that is you can go to explorer.solana.com, you click here, click custom RPC URL, and that should be set by default to your current local host, your current local validator. So we can just click that, and boom, we have that. We can see a bunch of live stats. So 1,300,915,916. We can see that roughly matches up. This will be based off of the finalized slot. They're equal from the front end to the back end. And using this Explorer, you can see a lot of the different things that you're doing locally and making sure that you're validating your transactions. You're making sure that the instructions that you're setting are correct. This is the full local setup so that you can actually run all of your code locally, iterate a lot faster, and not have to worry about other environments. It's very important that everybody, and this is what we're going to be doing throughout the whole bootcamp, is everybody uses the local test validator and gets very familiar with how to use it correctly. All right, so we have it running. We have our developer environment running. We have the voting DApp running here on a website. We can see I'm connected to it. We're all good to go. Everything is ready for us to get started on local. This is all the setup that you needed to start building local development on Solana. What I like to do is before we build anything on the voting DApp, I want to make sure that we understand exactly what we're going to build. We're going to architect all the different things that we're going to build before we actually write the code. This is so that we kind of understand what we're thinking when we build out the application so that we don't have to keep rewriting the same code over and over and again. So I'm going to draw it up here, and we're going to give the full architecture. All right, so this is basically a whiteboard. I'm going to use this to draw out the voting DApp. We're going to create a voting application that's going to do two things. We're going to either be able to vote for an account. We're going to vote for crunchy or smooth peanut butter, basically. So if anybody wants to vote for their favorite peanut butter, say you enjoy crunchy better than smooth, vote for that one. And then if you want to do smooth versus crunchy, vote for that one. It's a very easy way to showcase. But you can kind of see like how this extends to real-life applications, say like an actual election or your school representative election or something. You can actually decentralize this to where every single person has a public and private key, like you learned early in this boot camp, and that is their identifier. And you know that they voted, and you can immediately count the votes that they have for a specific candidate online. So let's draw this up. Okay, so part of this diagram or this architecture is we have to understand what accounts that we need for our smart contract before we write it. So here we'll be creating basically polls, right? So we're going to have a poll account. We know that. And then we're going to need candidates. So we're going to create another candidate account. We're going to have, I think what we're going to do is for each candidate, we'll have an individual candidate account. So there could be multiple of these. So let's just create a bunch of them so that it's easy to remember. And these candidates will have some information. So each of these accounts, since these are both different types of accounts, will have different information about what is the poll and what is the candidate. So the candidate, it makes sense to have candidate name as who you're voting for, and then maybe there is a candidate vote amount. This is so that you can keep track on chain via just looking up the account, how many votes a specific candidate has. And in the poll, we're going to have a different amount of data stored in it. So we'll have like a poll name. This can be like the question or the name, or yeah, this could be, let's call it poll question. That'll work better. Or we'll just call it poll. That'll work. So we have the poll, like what are the question, what's the answer, or the question that they're asking in the poll, like Do you vote for, in our case, crunchy or smooth peanut butter? We'll have a description that kind of tells you a little bit more information about the poll so you can better vote what candidate you want. We're going to have a poll start time. So let's do poll start and poll end time. And then we're going to do one last thing that helps us understand more information about the poll and also do lookups later on. Because one of the things that we're going to have to do is we're going to have to do lookups on how many candidates there are within the poll. So we might have 5 candidates, we might have 2 candidates. In our case, we'll only have 2. But say we have hundreds or something. We want to make sure that we understand how to do the lookups correctly and very quickly. We'll call it candidate index. Or candidate amount. We'll call it candidate amount. All right, so we have our 2 accounts. And if you remember as part of the PDAs, or program-derived addresses that you used in the previous project, we want to figure out how to find these accounts and do lookups on them very easily. So we're going to have to derive these things differently so that's very easy for us to do those lookups. So let's get into that. The way that we derive PDAs is we provide seeds. So in this case, for the poll, we will have a poll ID. This is so that we can get the poll and figure out which ID this poll is. So this is like if you have a list of different polls that you are doing lookups on, this helps you understand which poll ID represents whatever poll that you're pulling from. So there's 2 ways that we'll have to do this later on in the actual application. You can either do just a incremental ID where it's just like 1, 2, 3, 4, 5, etc. Or you can do UUID as the poll ID. I think we'll just do 1, 2, 3, whatever. And the way that we'll have to do lookups later on is we can either cache it server-side on the amount of IDs and what are the polls and descriptions, and then just do verify on-chain, or we can just do like incremental lookups and figure out, okay, what are the first 10 polls, showcase them on the website. There's a lot of different things you can do with this. We'll do a lot of that later on in the bootcamp when we productionize this application. But for now, we're just going to have poll ID. It's going to be a number, and that's it. And that's how we're going to derive the poll. So this is the seeds for the poll account. The other one is we have candidates. And what I would like to do for this one is for the seeds, we would always want to make sure that it's identifiable based off the poll ID. So that whatever poll that we are pulling from with all the information, it's uniquely tied to that poll. This poll ID directly ties it to that poll. So we'll do poll ID, and then just so that we can do lookups based off of which candidate, we'll do the candidate name as well. So this ends up being our 2 seeds that we use to derive each candidate. So we have the seeds of poll ID and seeds of poll ID plus candidate name. The whole reason, and you have to make sure that you give these different accounts a lot of thought, but the whole reason why we're doing this is so that we don't have to redo our accounts later and redo the way that we do lookups later, because it's very important that we have good lookups at the beginning of building out our program or our smart contract so that we don't have any issues long term. All right, so here we go. We have our poll ID and our candidate name. And we have to also build out what are the instructions, what are the functions we're going to call within the smart contract. So let's go outline those out. So the first one that we'll need is, let's pull this over here. I'm going to move some things around so it's easier for us to view everything. The first thing that we'll need is we'll need an instruction. So we'll call these instructions. We'll need the instruction for initializing the poll. All right, so this will build the poll, take out all the parameters in order to build that poll, as well as the poll ID, and it will have everything we need to build that poll. So the next one that we need is we're going to have to initialize individually candidates on this poll. So this is initialize candidate. All right, so we have the poll, we have each candidate. The last thing, and the most important thing, is you can't have a voting application without the ability to vote for application. So we have everything we need. We have the instructions, we have each account. Now we can actually just start building. So let's go over to our local environment. You can open your favorite IDE, and you can just start building there. So I'm going to open Visual Studio Code, and I'm going to go open the specific folder that I created earlier with my voting D app. Okay, so I have the whole code base open now that we created earlier via the create Solana D app. We can see, just as a quick walkthrough of this actual scaffold, we can see here we have a web. This has just a basic Next.js app. If you're familiar with it, or if you're unfamiliar with it, that's okay. We will show you what's practical to get started. You don't have to go end to end. Basically, it just has a bunch of components, and within these components, you'll be able to see, so it was originally a counter page. This is the page for that. And then we have a bunch of information in order to get the counter. We have a data access. We have a feature which helps us actually showcase what that counter create is. And then we have that UI for the page. Don't worry about it if you don't know this too much. We'll just go through what's practically needed to build out the website. If you want to learn how to build websites or build the UI or the front end for any of these applications we build throughout this bootcamp, there's plenty of resources online that you can use. We're more focused on building the Solana side of things rather than the UI throughout this bootcamp. So we'll teach what's practical throughout this. All right, so this is everything that's in the web folder. And then what we're going to focus here is we're going to focus on the anchor folder here. So if we go here to programs, source, lib, we'll see that there's a counter program already based in here. We want to update that to our voting D app. So we're going to update this to voting. I'm going to just remove all of these instructions and then the rest of the accounts. So you end up having this very small file. There's barely anything in this file. I'm going to do a couple other things where we're going to change. We're going to change this one to say voting as well, this file. I believe in here it also says voting. Basically, you can change everywhere that says counter to voting. If you use this in the future, it should be automatic, and then right now it's not. So one thing to note is that we need to also double check our anchor laying is the one that we expect. Throughout this whole bootcamp, we're using 0.30.1. I don't know in the future what the new versions of Anchor might hold. So if you're ever in the future using this, say, I don't know, months in the future, and we're going through this bootcamp, and you're using 0.31 or 0.32, and something doesn't work, definitely make sure that you use the right dependency. Also, as a general note, if you ever run into issues, you can always double check the project link in our GitHub repository. It will be in the description below, and you can go to that and check all the code and make sure that you're all set up correctly. All right, so we have the right Anchor version. We have our librs. The first thing I'm going to do, just to make sure that I did everything correctly, is I'm going to go cd into Anchor, and I'm going to do an Anchor build. This is how you build your smart contract locally. And let's make this slightly bigger for people to be able to view it. And so this Anchor build will compile our smart contract, and I'm going to do it early just to make sure I didn't screw everything up. I often will say build early and often. You'll hear this throughout the whole bootcamp on whoever's teaching, so that you don't have to run into issues later on and be missing a bunch of errors. You would rather run into the error as soon as it pops up rather than working backwards in your code. All right, so this built everything. You can see that it gave me a warning. This is because I'm not using this yet. We'll use it later, but that's okay. We'll work through it. So going back to our diagram, we can see that we had two instructions, or three instructions actually: initialize poll, initialize candidate, and vote. So we can just actually build those out right now. So in order to build those out, we can see that, so I actually have Copilot installed. I will also be using Copilot throughout this. Highly recommend using it. It's really useful. You can already see that it's trying to get me to create an initialized voting instruction. I'm going to ignore it and just do it myself, but it's a cool thing to go through. So we know that the public function, and we had this as initialize poll, we have to initialize the poll first. And we grab the context. So this is context. We're going to call it initialize poll. we're going to give it a poll ID. We're going to make this like a U64, so you can just have a bunch of polls. And then we're going to return, right now we're going to return OK. All right, so that's a base instruction. I'm going to create underscores here. So these underscores are basically just to denote I'm not using the variables, just to remove the warnings. We're going to anchor build, make sure we do everything right. So we can see that something went wrong. Let us make sure that we do it all correct. Oh, it's because the initialize poll we haven't done yet. So let's get started with that. All right, so one of the things that it noticed actually before we get started is that the program result's not correct. It's actually result, and that is correct. So now if we do a clear, so let's do a clear real quick and then rebuild, it should just have the context error. So there you go. So you have the context of initialize poll is not found. Perfect. So let's go build it. So if you remember in the previous example or previous project we built, we used the account macro or the derive accounts macro. So derive accounts. And we're going to create this as a struct called initialize poll. You can see it's, Copilot kind of already knows what we're doing. Doesn't know entirely, but we're going to create it ourselves. So struct initialize poll. We're going to use a lifetime for this. And then we have to create a bunch of different accounts within this context. As part of this initialize poll, we're going to be creating accounts. So that means we need 2 accounts already. We need the signer, and we need the system program. Now, Anchor is really nice. It'll actually pull in the system program already to you, so you don't have to worry about that. We'll just need the signer. So let's go build that signer. So it would be, because we're getting money from it, it's a mutable signer. And then we just have this as a pub. I'm going to call it signer because it's just nice. Signer info. So we know this is getting created. Perfect. Great. We have a signer that's going to be used to pay for this account. So next thing that we need to do, if you remember correctly, we had the poll account. So we need to create an account for the poll. So let's go ahead and create it. So account, and I'll fill everything in just a moment. We just want to make sure that we set it up. So poll, this will be account info poll. That works out. And down here, we're going to create that struct real quick. So I'm going to use account. We're going to do pub struct poll. And we're going to put everything in this. So we're going to have a pub, poll ID. So it already kind of knows what we're doing. Thank you, Copilot. So we're going to have a poll ID. That's going to be U64, as we mentioned earlier. We have a description. So this is pub description. We're going to call this a string. We have a poll start. So pub poll start. That's also going to be U64 because that's how you measure. It's going to be a Unix timestamp. We have poll end, which is also going to be U64. And then we have a poll index. We can have this, well, we had it as a candidate amount. So candidate amount. And we're going to have this as U64. So this is everything in our poll. This should be everything that we need right here. And so we should be able to create it right here, create the account right here. So let's go build it all. If you remember last time, and Copilot is giving us all the answers ahead of time, is that you can use init to make a account automatically initialize. The next thing is we're going to have the pair. We have to denote which pair it is, so we're going to have to give it the pair. We have to give it the space involved. And so we had some variable stuff here. We have a string. We have a bunch of U64s. U64s, we know how many bytes they are, but the string might be a different amount of bytes. So we have to use something called max length to give, it's in a macro, to give the max length that this string could possibly be. So let's go ahead and give that right here. All right, so to do that, we're actually using a macro called max_len, and we can just give the number of characters that this string can possibly be. So I'm going to just put 32, and that should be good. I think that's good enough. We could give, I guess we can do like a Twitter post. 280 characters. You can put a whole bunch of description in there. That should be good enough for this. So we have the pair, we have the size, and we're going to do another thing. There's another thing called init space that allows you to automatically calculate the space, and you don't have to do some extra work or math in your head to figure out how much space this is called. So in order to do that, you do hash, it's going to be derive init space. And so this basically allows you to get the space very easily. So when we do the space here, you can do space, whoops. It'll be always 8 because the way that Anchor does in the current version is that it always has 8 bytes reserved to it. So 8 plus poll init space. I believe it's actually init space. There we go. And then we need the seeds. So if you remember earlier, we have the seeds as the poll ID. So we can actually pull that in and use that as a seed. So we're going to do seeds. You can see it has poll as ref. It's not exactly what we're going to do, but that's okay. We'll update it. All right, so the way that you pull in different parameters that you use is you'll actually use a macro called instruction. And you can see it pulls in the poll ID as a U64. And then what you can do is you can then use the poll ID. I think it's as ref. To do a seed for this poll account. So this seeds sets up the poll ID as seeds to get that poll account. And then finally, as explained earlier, you always need the bump. So we always have the bump in the poll. We have the signer, we have the poll. And I believe we can just run this now. Let's go ahead and do anchor build. Build early and often. Let's see if we run into errors. We did run into errors. Let's go fix them real quick. So traits bump, blah, 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 poll. Okay, so let's see. Oh, let's keep going up. Not found in scope. So it looks like something is not set as the same thing. Let's see, I did use that correctly. Undeclared usualize. We always have to go to like the top error. Good thing about the Rust analyzer, the Rust compiler, is it actually gives really good errors. So it says here, the program, okay, cool. Initialized poll is not found in the scope. So something is wrong with this initialized poll. And that's fine. We can get there. All right, so we can see here, just looking at the error, the top error is use program type to add a system program field to your validation struct. This is because I'm creating an account, I actually need the system program. So pub system program, it's going to be a program of info system. So let's go rebuild it. Should have one other error, and that is fine. Okay, so now we have another error. We can see that other error disappeared. We can see that, oh, I understand. I did pair. We actually called it the signer. So it's just, that's okay. There's some misspellings. We do anchor build, and it looks like it's building. So that wasn't that hard. Just as a heads up, if you ever do run into errors, definitely go to the Solana Stack Exchange, if you can't figure it out, and ask a question about the errors. It is very important when you do ask a question, however, to provide all the code necessary for someone to reproduce your error. If you don't give all the code, they might not be able to have enough information to give you an answer how to fix your code. So right here we have anchor build, and voila, we have initialized poll. However, if you know right immediately, you can see we don't do anything with the poll. We have the context, we have the poll ID, but we just return OK. Now, note with Anchor, and this took me a while to figure out my first time, is that if you have this init, it does create the account. So that is OK. However, there's nothing in that. So we need to give some information to it. So some of the other stuff that we have is we have a poll start and end. So we actually have to have that passed in as part of the parameters. So let's go ahead and add those real quick. And I'm going to take out the underscores because we're going to start using it, using all of these different things. So next thing is we have a poll start. This is going to be the U64 we're going to pass in. And then we have a poll end. That's also going to be a U64. And then finally, we have this description that we talked about. And we're going to, for this last variable, this candidate amount, we're going to use that to increment later. We don't have to do that in the initialization, but we do need to make sure that it's set to 0. So let's go ahead and set it. So we're going to do let poll equals mutable context.accounts.poll. This is so that we can update the poll account. And we're going to set everything. So poll ID equals the ID we passed in. The description is the description we passed in. We will make sure the poll start is set. And the poll end is set. And then the candidate amount we're going to set as 0. So this is everything to initialize that poll. So we have our first instruction. We're all good to go. So an important part of local development is testing your smart contract. What we're going to do is each individual instruction that we build out on this voting application, we're going to test using a testing framework called Anchor Bank Run. So let's go pull that up. All right, so if you just look it up, it's called Anchor Bank Run. And you'll see that it is a testing framework that allows you to test your smart contracts methods or your instructions and make sure that you're expecting the right values to come out. So let's go test it out. So the first thing that you need to do is you'll have to do this yarn add anchor bank run thing. I'm using npm, so I'm just going to do npm install. Use whatever your flavor package manager for Node is to install it. So it is called Anchor Bank Run. All right, so we've installed it, and now we have to get started. So if you go over here, there is a counter spec.ts. You go click on that, and there's already a test in there for the counter program. We're not using a counter program anymore, so we're just going to remove all of the information within it and create a new test. So let's go remove the whole thing and remove some more of the code. And I'm going to call this, or let's remove the counter because it doesn't exist. I'm going to call this voting, and we're going to call this initialize voting, or initialize poll, because we're initializing the poll with our instruction that we just built. So going back to the actual code, there's a few things that you need to do ahead of time in order to make sure these tests run. So one of the things is you'll have to go grab the program, the smart contract binary, and paste it into a folder called fixtures so that it knows what smart contract to use. We're going to do this manually now. However, later we'll do some things to make a trick to where it automatically copies over whenever you do build. So right here in target deploy, you'll see a voting.so file. We're just going to copy it, and we're going to paste it into a fixture. So create a new folder called fixtures and paste it there. The next thing that I'm going to have to do is I'm going to have to pull what's called an IDL, which is kind of like an interface to help build and generate language-specific format for calling smart contracts. It's, if you're familiar with like Ethereum or something, it's similar to the ABI in those ecosystems. So I'm going to go grab that. We can see here, this is the voting IDL. It is under target IDL. It's called voting.json. We can see here in the example here that it is const IDL equals require the Puppet JSON, which is Puppet is the smart contract that they're using in this example. All right, so let's go copy it over. So we're going to do const IDL equals require, just like the other one, except we're going to grab voting.json. So it grabbed it immediately. The other thing that we're going to have to do is we're going to have to grab the program type. So our program type is under the types folder, which is under target. So let's go grab that. So we'll just import it. Import, it'll be called voting in our case, from target types voting. And so we have the IDL and voting. Now we can create what's called the context and provider that allows us to interact with our smart contract. So let's just copy these, and we can get to using them in just a moment. So I'm going to put them right here. You can see it's erroring out. That's okay. It's because it doesn't have start anchor. We can just import it real quick. Let's say import. We can grab it over here and import at the top. Perfect. So it knows what it's talking about. Our tests are local to our folder, instead of this test, which are in a specific test folder. So we just leave this as nothing, because it's just going to test what's there. And then there's, if you look here, there is extra program, which is added programs and accounts. We're going to not do anything for the added accounts, but we'll do something for the extra programs. We're going to need the program ID, so I'm going to create a public key right here. This is going to be voting smart contract address, or voting address, let's call it that. And we're going to call it, it's a new public key. And we're going to copy the same public key that we have within our code. So if you go over to your lib.rs, you can copy over the ELY. For my case, it'll probably look different for your voting contract. So now we have the address, and we can put that in our thing. And if you look at Start Anchor, Added Programs, it has a name and a program ID. So we have to go add this right here. So we're going to do name. I'm going to just call it voting. And the program ID is just going to be our voting address. There we go. So we have the context, we have the provider. Now we have to create the program object. So you can see here that the program object is just created using the program type. So our type is called voting with the IDL and the provider. So this one's going to be called voting program. All right, so we have everything to get started. And Anchor makes it very easy to interact with different smart contracts using the IDL, because with this voting program, and you can already see Copilot telling us what to do, is we can actually just do await voting program dot methods dot initialize poll, and then give our parameters. All right, so we have initialized poll, and that's our method. And if you look at our previous, our actual instruction, it has poll ID, description, poll start, and poll end. So let's fill that out. So in order to do a U64 in TypeScript, you have to do new, and you can see it already knows what to do, anchor.bn, and we're going to have the ID of 1. The next type that we need is we need the description. So we're going to create this, what is your favorite type of peanut butter? The next two U64s that we're needing is the poll start and poll end. So these are actually Unix, Unix timestamps. So let's just go pull a Unix timestamp real quick. UnixTimestamp.com, copy the timestamp, and we're going to do another new anchor bn, big number. I'm going to do this at the beginning of existence at 0, and then we're going to do another one at, we'll just add a bunch of time at the end. So let me go grab, didn't grab this, so let's just grab that real quick. There we go. So I'm going to add a bunch of time at the end. This is just increasing numbers significantly. This will be much in the future. So if I were to like copy this and paste this to convert to see what time it would be, this is in 2027. So it's years ahead of our current time, and we're good to go. So now we do the initialize poll. The last thing you need to do is you actually have to call the RPC with it. So this .rpc after the methods call actually will call the RPC to execute the instruction within the program. All right, so we've done that. Let us test it and see if it all works. So anchor test. All right, so it tested. It ran, looks like it ran, found test screen. Error configure port is already in use. So one thing that we need to do is with anchor tests, we're already running both a validator, a Solana test validator behind the scenes. So we actually needed to skip it. So skip local test validator, I believe. Or maybe it's local validator. It's always good to read the manual beforehand to see if what you're doing is correct. So you can see it's skip local validator. And then we also need to do skip deploy because we're using Anchor bank run, which allows us to skip a bunch of steps and run directly within the validator, or what's called the bank part of the validator, instead of running on a very heavy lift of the local test validator. So let's all run that. So anchor test skip local validator and skip deploy. And so this will run our test. You can see here it's found our test script. It's loaded our program. The one thing that we'll see right here is that it's going to fail because it doesn't know what this voting program is. And the reason being is you can see here that it says counter. And that's not running one of the recognizable program names. So let's go update that. If you go over to Anchor TOML, you're going to see that in here we have programs.localnet counter equals that address. So we need to update that. So let's go update that to our current program, which we called voting. Then we run the tests, and if everything is done correctly, it will pass successfully. So we can see here, it tested our voting program from our binary file, and everything looked like it worked correctly. It did the initialize poll check. Now, note, this is not a good test. It doesn't do anything. It doesn't check anything. So we actually need to go pull that account and make sure that we did everything correct. So one thing we're going to have to do is we're going to have to go grab that poll address. So this is going to be the poll address from our program-derived address, because if you remember, our seeds for the poll account is the poll ID. So we have to do this dot public key dot find program address sync. And we have to give the seeds. So the seeds will be, it'll be buffer, actually it'll be new anchor dot bn of 1. So that is the actual .tutor array-like buffer little endian 8 bytes. This is how you grab the buffer from a U64. So we have that, and then finally we have to give the program address. So this requires the seeds and the program address. So that will be the voting address. Perfect. So this should be a poll address that is going to be created based off of this initialize poll instruction. And let's go verify it. We're going to first console log it. We're going to grab the poll account and then console log it. So const poll equals await voting program account poll fetch poll address. So this is saying, hey, fetch the poll account off of this address. And now we're going to console log it. All right, let's go see what it looks like. All right, so we can see it passed. And we can see right here, we have our poll ID of 1. We have the description there. Poll start is at the beginning of time. Poll end is this number. And then candidate amount, there's no candidates yet, so we have 0 candidates. So we've tested it, all looks great. It's fantastic. Now we can do some expects so that this test is actually a good test, because currently it doesn't actually test anything. So let's do some of those tests. So right now, we can do 2 of them, because we have the poll. We can go grab it, and you can see it says poll ID to number equal 1. And then we can do another poll. It's not the question. Whoops. It's going to be the description. Equals this, what is your favorite type of peanut butter? And then we can also do, just for good measure, we can expect that poll description, poll start to be less than, so let's go grab that. Should be less than poll end, because we know that it should always be under that amount. So let's go, also we have to change these to numbers, otherwise it won't work correctly. Poll start to number. All right, so let's test it. Make sure that our test actually passes. All right, so our test passed. You can see the poll got logged, and the poll account was actually initialized. So we've done everything to initialize the poll. Now we can get to initializing candidates, which will be very similar to what we just did to initialize the poll. So let's go back to the program and start building that out. All right, so the next instruction, if you remember from this diagram over here, is we have the initialize candidate. So let's go build it out. It's going to be initialize candidate. We have to create a new context using different accounts. Context initialize candidate is the context name. We're going to have the candidate name. And do we need anything else for a candidate name? We don't need candidate votes because they're going to be set at 0. We also need the poll ID, otherwise we can't pull the right poll that this is related to. It's going to return. We're going to just have a OK return first. So let's just return OK. All right, so we have that. Now we need to go create the actual account struct. So let's once again, we're going to do derive accounts. We're going to use, if you remember, one of the seeds is the candidate name, and the other seed is actually poll ID. So we need both the instruction information. So this is going to be instruction candidate name poll ID. One thing to note, at the current time, you need to make sure that they're in the same order, because it'll actually pull the parameters after the context in the same order that they are listed in the actual instruction. So if you don't have them in the same order, you'll actually get the wrong data. So just a quick note, this will be pub struct initialize candidate. All right, so there's a few things that we'll need. So as we saw last time, we absolutely need the system program because we're going to be creating a candidate account. Same thing, we're going to need a signer because someone has got to pay for that new candidate account. We're going to need the poll because we have to use it to increment the amount of candidates that are within the poll. And then finally, we need the candidate account, which we'll do in just a moment. So one thing you might have noticed is that in our poll account, we originally had payer, signer, space. Because we don't actually need to create it, we're just referencing it, we'll just do seeds equals the seeds and the bump. Finally, let's go create our other account. So this will be a new account. This will be a candidate. You can see it already started pulling everything. We'll have the poll ID and the candidate name, so it's just a separation or switch of these two, and those are our two seeds. Then we have the bump. So then we go to pub candidate account info candidate, and now we have to go create that actual candidate account. So once again, account pub struct candidate, and it's going to have candidate name and candidate votes. All right, so we have the candidate. We have all the information for the candidate account. One thing that you note, we used init space again, so we're going to have to derive init space yet again, like we did on poll on candidate. And let's do an anchor build, just to make sure. We've done a lot of code. Build early and often. You can see I made a error here. It's because I used string, so we must use a max length. We can do that again and grab this on the candidate name. So I'm going to say the candidate name, the names are normally not longer than 32 characters, so let's lower that to 32 characters. Probably lower it even more to like 16 after a little bit of testing, but that's okay. You can see that we got a bunch of warnings. These are just because we didn't use these different parameters yet, but it did build successfully, which is a good thing. That's why you always build early and often, otherwise you have to go redo a bunch of code. All right, so we have a candidate name, we have the poll ID. Poll ID is actually never going to be used, so we make sure that it is underscore. The candidate name will be used, but it's not. It's going to be used like this. So we can actually make that underscore as well to get rid of that error. It's going to be used in the instruction down below. Final thing is we have the candidate. So some of the things that we're going to have here, actually the candidate name will be used. All right, there we go. So we're going to set the candidate name in the account. So let candidate equal the mutable context accounts candidate. So we grab the candidate account, candidate name equals candidate name, and then candidate votes equals 0, because you need to always start with 0. Let's go build that, make sure it works all right. All right, cool. So I pulled this. We have the initialized candidate. All right, so now it's time to test initializing the candidate. So what we're going to do is we're going to create a new test right up here. It's going to be integration test initialize candidate. And we're going to test making sure that we're actually initializing our crunchy and smooth peanut butter and everything works as expected. So we have this. I'm going to also create, just for the future reference, because we're going to have to vote, I'm going to create a vote test because we know it's going to happen, so might as well have it there. So we have a vote test. And now, because we have multiple tests, I want to make sure that I pull this context provider and voting program out so I never have to use them again. So we're going to quickly set them over here. So this is context, let provider, and let voting program. And we're going to do a before all. And we're going to create a function that runs and sets these so that we always have them before every integration test. And we just pull these guys right back up there. Oops. There we go. Copy and paste. Remove the const. This is an async. And we got to remove these consts as well because they're always going to use the provider and the voting program from above. Actually, we don't even need them at all, so we just remove them. Perfect. All right, so let's run it, make sure that it still runs. So we don't want to have to have done all that and it breaks. That wouldn't be great. All right, so we have all our three tests passing. The initialized poll, as expected, is doing what it needs to do. Initialized candidate and vote don't do anything yet, so I hope those passed. It did. So now let's build the initialized candidate one. So it should be very simple. We should just be able to call the initialized candidate instruction. So if you remember the vote program or the initialized candidate program, it took a candidate name and then a poll ID. So we have to go put those both in there as parameters. So this one's going to be, we're going to switch it to be smooth first and then the number. Make sure you set the name first or set the same parameter order that you had in your instruction, otherwise you will get an error. And so this is our ID of our poll for smooth. I'm going to do this twice for both crunchy and smooth. I'm going to see if it runs. Let's make sure it runs correctly. All right, cool. So I was able to create the crunchy and smooth candidates. And I believe if we run it again, okay, so it's doing the initialized candidate. Perfect. Okay, so we've initialized those two candidates, but that doesn't really mean anything unless you actually grab the candidate. So let's go grab them real quick. So const, we need to go get the crunchy address. It's going to use find program address sync. And if you looked at our actual, our seeds, our poll ID and candidate name. So one of the seeds is already there. The first seed is poll ID. Let's just verify with our lib.rs, our actual smart contract. The first seed is the poll ID, then there's candidate name. So let's set that up correctly. So poll ID should be first, which is new anchor, let's just comma, anchor dot bn, and it's what we had earlier. So if we can just pull the same code that we had earlier to array like buffer le, or the little endian 8, and crunchy. So that's the crunchy address. And then we can just for before we move forward, let's go grab that candidate. Crunchy candidate equals await, get the candidate count, and let's go console log it. All right, so let's test it. All right, so you can see here the candidate name is Crunchy, candidate votes is 0. Let's grab the other candidate. So I'm just going to copy and paste this code and change everything to use smooth. And then once we have all that set up, it should be ready to go. There we go. So I've copy and pasted it. Now we have all smooth. And we should be able to see the console log for both smooth and crunchy. There they are. They both have 0 votes. Perfect. So we have all those things. Now let's actually do some real tests. So you have to, I'm going to set them all because we just initialized them. The most important thing is that the votes should equal 0. So if you look over here, the candidate account, let's go grab him real quick. His candidate votes should be 0. So it's going to be candidate votes equal to, I guess it's 2 number, is equal to 0. New BN, new anchor, because we have to make sure it's equal to the U64 big number format. Let's make sure that works as expected. Perfect. Okay. So expected 00 got 0. So it's equal to the same. We just have the wrong format. So let's update that. Candidate votes to equal. I think it's because it's already a big number, so we have to make sure it equals the same. There we go. Let's see what it got. 0, 0, received 2. Interesting. Let's see what we did wrong here. So received, expected, received was 2. Okay. So it's probably because we did the, let's see, candidate votes, big number. So I think we can just do 0 here, actually. Let's check. There we go. Because we send it to number. There we go. So we set it to number, and it's equal to a number versus the big number equivalent. So this expect, we can copy and paste it right over here. And we can use it for the same smooth candidate. And so now we have 2 tests to make sure that their votes are 0, because that's the most important part, that whenever you initialize, they initialize as 0. Because if they initialize as more than 0, then it's basically cheating the system. You're getting more votes for your candidate than you previously had. So next thing, we're going to create a vote instruction. So let's go create that right here. So it's going to be pub function vote. See, it already knows what to vote. We're going to have, it says candidate ID. It's not actually a candidate ID. We're going to be voting for a specific candidate name. And there's our string. It's going to output a result. One of the things that we actually didn't do in initialize candidate, now that I just remember, is that the poll, if you remember correctly, the poll had a candidate amount. So we actually have to also increment the poll. So let's go do that real quick. Equals reference poll, and then do poll plus equals 1. All right, so that's set up. Our vote amount is we have to grab the candidate from the candidate accounts, because we're going to set up this vote context in just a moment. We'll call it candidate, so it's all the same, and just plus equals 1. So let's go create that vote context. So once again, drive accounts. There is nothing, is there anything? Okay, so we still need the candidate name. It needs the poll address, because you have to vote for a poll address. So let's grab that as well. It's going to be the same thing as over here, actually. There we go. So candidate name, poll ID. So it's going to be the exact same thing. We're going to have to pull a lot of the same accounts, except for you're not going to have to create any accounts. So we can remove the system program because we're not creating accounts. You can remove all of these initialize things. So you just have the seeds and bump. Do we need the? We need the signer because there's still a signer on the address, but it's not mutable because it's not paying for an account. And then we need the pub struct. So we called this the vote context. So we need to make sure that we set that correctly. So pub struct vote, and let us anchor build it. Let's make sure I didn't mess up anything. It looks like I did run into an error, so let's just double check. Oh, it's because I don't have the lifetime set up on the struct correctly. So that got rid of some things. And then, let's see, the public account could not resolve. That's specifically the signer because I'm not doing anything special with that. Remove that, and it should all work. There we go. One thing that it said is that it didn't know what to do with candidate name. I think it's because it's in here and doesn't actually use anything. We're just passing it in so that we can derive the account successfully. So now, since we added the underscore, it should compile with no error or no warnings. There we go. It works. So what we need to do, once again, you copy and paste. So copy that voting.sol over here, voting.so over here into fixtures. And then we should be able to write the spec, the test for it. So let's go vote for one of our candidates. So what we can do is we can do an await voting program dot methods dot vote, and we have to vote for our specific candidate, and we have to always remember to hit the RPC. All right, so what we need to do is make sure that we're always going to pass the same thing, so candidate name, then poll ID. So the first candidate name will be our same ones that we did earlier. So right here, I'm going to vote for smooth, because that's the kind of peanut butter I like. It's going to have a poll ID of 1, and that is fine. And then we have the RPC calls it, and let's see if that worked. Let's see if this part just worked, because that'll tell us whether or not the RPC worked. So let's do anchor test. Remember always to skip local validator because we're using bank run, and then skip deploy because once again we're using bank run. So we get to skip a bunch of steps and see if it worked. So it worked. However, we don't know what actually happened. We can see that the vote actually was working here. So we know that it's actually voting, which is great. We know that the vote instruction is being called. We don't know actually what it's doing, though. So let's go grab that vote account and verify exactly what is happening there. So we'll have to go and get the address. So const, we'll have to go get the smooth address. So it's actually, we can copy and paste this up above and then just pull it from there and expect it equal to 1. So let's go grab it. So the smooth address, it is the same address as before, voting address. We have the smooth candidate, and we need to make sure the equals to 1 now because we have voted for smooth at exactly 1 time. So it ran into an error. Let's see what it expected. Expected received 0. Okay, so let's figure out what happened here to where it did not increment 1. Did we actually plus 1? Candidate votes to number. Smooth candidate, so this is fetching the smooth address. It should have incremented because we did a vote RPC. That should have worked. Let's see, expected 1, received 0. So something happened to where it did not increment. So let's figure out what happened. So we have the candidate. we have the candidate votes, we did a plus equals to 1, and we sent an OK. So why did this not increment? Let's figure out. So one thing that you can always do is you can actually send messages or logs to figure out how many votes something has in your smart contract. So we're going to anchor build this, and I'm going to pull this over and verify that this logic is working as expected. If it works as expected, that's great. We're good to go. And we're just going to need to figure out what else might have happened. So let's go copy over the .so again. We copy and paste, and let us test it. And we should be able to get logs, the program logs, that it tells us exactly what happened. So we go up here, we can see the votes for 1. So something was being pulled that did not happen as expected. So we got voted for 1, that's great. It came back, it was 1 vote. We did get it afterwards. I wonder if let's go pull the actual account address. So smooth candidate, fetch account address. It should have happened after the vote. It's perfect. All right, so this is actually a really good point to make. It did not increment earlier because even though the library was saying I incremented whenever we did this message. And this is because all accounts by default are immutable on Solana. So unless you say that the account is mutable, it will not actually update the account, even if you pull in the candidate account as mutable. It doesn't matter, because by default, this candidate account will also always be immutable. So we actually have to go here, and we have to make sure we declare the account as mutable. And we didn't do this earlier, so actually the poll account also didn't update. So I'll add those 2 things. So now that we added mutable, so let's do an anchor build. All right, and then we got to copy over our .so file again. Copy it over to our fixtures. And then let us run the test. Perfect. So all 3 passed. We can see that the candidate vote for smooth is 1. We can see the error, it's not the errors, but the logs went from 0 to 1 here, as expected. And from here, what we have is we have a fully working voting smart contract. We have tests that test it. And that's all we're going to do for this project. We have all the stuff on the smart contract side. Everything's interacting. We've run tests on local. We've run everything locally on the local test validator. We have our full local environment set up for success. In the next project, we'll actually be using this vote smart contract and putting kind of a front end on it, but making it more social. So look out to the next project. And for that, I will see you next time.